So a radical function is really any expression that is underneath the root. So x could be any expression or numbers. I'm just going to write that down here. Right, or number. And it's all under the root. Now, the general form root x. If we look at the domain, we see that it starts at 0 and then increases infinitely this way, unless restrictions are placed on the function. So we would say that for the general radical function, one of the properties is that the domain is always equal to or greater than 0. So we could write it as 0 is smaller than or equal to x. Or you could write it as x is greater than or equal to 0. Now the range also starts at 0. So we could say that 0 is smaller than or equal to y. And in this case, y is approaching infinity, right? So we don't have to write anything here per se, unless, again, restrictions are placed. There's an x-intercept at 0, right? We could see that it actually reaches or goes through the graph at x equals 0. And there's also a y-intercept of 0 as well. Now, this might be subject to change based on transformation, but when we're talking about the regular graph of the parent function y is equal to root x, this is the case for the y-intercept. The last property that is unique to the root x function or the radical function is that x cannot be negative. And if you try this out in your calculator, you're going to see that you're going to get a value of undefined. Now, the reason why that is the case is because if you think about root 64, the square root of something is the product of, in this case, 8 and 8. It has to be two of the exact same constants or numbers with the exact same integer. Now, if these are both negative, you still end up with positive 64. Now, if I go negative, so root negative 64, that means that one of these would have to be negative, making this not a perfect square because the integer is different. So this is not a perfect square. So that makes this expression impossible. And you could try this with any number and you'd see what we were saying. So the x cannot be any.